Yes, yes or no more. See, day order 5. Day order 5 have 6. See here, 3 sessions. First morning 2 sessions lab. The afternoon, the first session after lunch, theory session. Okay. So please note down that the theory sessions on day 1, day 3, day 5 only more. So previously that is day 1, day 2, day 4. So now 1, 3, 5. So very easy to remember. That is odd number. So day 1 morning 9:50 to 10:40. Day 3 afternoon 2:10 to 3, and day 5 1:20 to 2:10. So the three theory classes for group 2. So lab on day 5 10:50 to 12:30. Okay.
So this Saturday we will not be having our classes. So this Saturday we will not be having our classes.
No, I think Saturday, I think no day orders. Hereafter, I think. You please confirm your faculty advisor, please. Because now they go to follow the 5-day orders. I think most probably, you please confirm your class in charges. Respective class, faculty advisor or class in charges. Okay?
Okay, sir. Thank you.
Yes, yes, yes. So any doubts here? No.
No, sir.
Okay, okay. I go to stop the share screen. Okay, just wait. Okay, so now almost what is the time now? 3:05 now. I think now still only 37 is there. Why? So already you know today have the lab session from 3 to 4. I don't know why. I think today is only 37 is there, 36 or 37. But anyway, we'll start now. Okay. So first I go to share the screen. Please wait. Yeah, screen is visible for you.
Yes, sir.
Yes. Okay, so yeah, you just wait. We will start. Okay. See, today is that is the 11th experiment. What about so all of you submitted your assignments? That assignment 10, practical assignment 9 and 10, and theory assignment 2.
Yes, sir.
So those who are not submitted, please you go to submit. I think practical assignment still some 12 or 13 is not submitted. 9th and 10th also. So just now I check. So please, those who are not submitted, please go to submit the assignments. Experiment number 8 and experiment number 9, 10. Okay. Also theory assignment 2. Okay. So now, okay. Anyway, go to start that today's experiment is solar cell. The continuation. So already solar cell already we did characterization of solar cell. That is VA and VR characterization of the solar cell. So of the continuation of this, you go to calculate the efficiency of the solar cell. So now the aim of the experiment is to determine the efficiency of the given solar cell. So that is the aim of the experiment. So solar cell already we did. Okay, that experiment number 5. So already we did that solar cell. How you go to take the solar cell? What is the basic principle? Okay. So what is the basic principle? We are using the solar cell. Anyone? Quickly. What is the basic principle? The solar cell
Photoelectric effect.
Photoelectric effect. Photoelectric or photovoltaic? Yes?
Photovoltaic.
Photovoltaic. See, that is a multiple choice question. Please understand. So after only the one more next week only have the lab class. Okay. See that today is 11th experiment. The next week you have 12th experiment. That's all. All the experiments are over. So then the only 1 week goes to for repetition. Repetition means at least we go to collect any doubts or clarifications, whatever. Okay. Through the entire 12 experiments. So after that, you have model practical exam. So that model practical is nothing but online mode. but definitely they go to ask the multiple choice questions for each experiments. Okay, at least you go to prepare the principle, aim, formula, units, and etc. etc. So most probably they go to ask the questions. Okay, simply for solar cell, they ask the questions. What is the basic principle by using the solar cell like that? They give 4 options: photoelectric effect, photovoltaic effect, or Compton effect like that. At least you go to choose the correct answer. So please you go to prepare for your model practical exam. Okay, there is no question bank separately. At each and every experiment, you go to see what is the aim, what are the apparatus required. At least you know what are the apparatus. Then formulas and each a symbol in that formula. At least you know what is that. Then unit. For example, the efficiency of the solar cell also have the formula. Okay, I will you go to explain one by one. Okay, first the basic principle behind the solar cell already you know, that is a photovoltaic effect. So now you go to conversion of that light energy into electrical energy. There is no doubt. Now, how you go to calculate that efficiency? So here the efficiency is very, very important. Say, for example, the 1000 photon go to strike the solar panel. Whether all the 1000 photons absorbed by the panel, whether it is converted into the respected current or not, electric current or something. So that is definitely is not there. Okay. So what much amount of output power you get, that is you go to see. Then what is the input power? So the ratio between these two, you go to calculate what is efficiency. Efficiency is nothing but the ratio between output to input. So here, what is the maximum power output divided by input power? Okay. So that ratio only you go to calculate. So how you go to calculate? That experiment already you did, that solar cell experiment, and the maximum position you keep the panel maximum position and take the readings. The minimum position also you go to take the readings. But for this efficiency calculation, so you go to take the maximum position. So the solar cell is maximum intensity. That is a maximum intensity. So where you get the maximum intensity? Whether the panel is very close to the bulb or far away from the bulb. Anyone? So when you get the maximum intensity, whether the bulb is the panel is very close to the bulb or away from the bulb. Yeah, which one?
Close to bulb.
Yes. Okay. Close. For example, and the readings are they are giving a 10, 15, and 20 centimeter like that. The distance. At least you go to take the distance 10 centimeter. Okay. So the 10 centimeter gives the maximum intensity. Maximum intensity. The distance between the solar panel and the bulb is the least. You get at that time only you get the maximum intensity. So that position only you go to take the readings. So in our experiment already you take 2 readings here. That solar cell experiment is the experiment number 5. So please you go to check that experiment number 5. So already the 2 questions you take the readings. Minimum position, maximum position. So now you go to take that maximum position and assume the distance between these two is 10 centimeter like that. Okay, that assignment part I will explain. That is a 10 centimeter only. Okay, so that is 10 centimeter distance. Now come to how you go to calculate the efficiency. Okay, very simple. First you go to calculate the output power. Already I told. So how you go to take that power, the maximum power point? See here, that MPP. MPP is the maximum power point. So how you go to take this one? So whether you remember this diagram, anyone? I think already the solar cell experiment you draw the 4 graphs. So whether you get this type of curve or not? Say yes or no.
Yes, sir.
Yes. So this is a VI characterization curve. Okay, the V along the x-axis and the I current along the y-axis. But definitely you get the curve like this. So from this curve, so please carefully listen. From this curve, see here. So initially the current remains constant with respect to the voltage. So then the voltage goes on increasing. See the current slowly decreases and it will decrease further and further. So where the curve is bent. For example, here only the curve is bent like this. So in this position, you go to make a dot here. Then you go to draw the straight line. Maybe the straight line, that means from the origin, exactly at the x and y axis where they go to meet. You draw the straight line passing through this point, and from that point you draw the perpendicular lines along the x and y axis. So they go to cut the x axis and y axis at one place. That the corresponding value you go to see, that is VMP and the IMPP. That is VMPP means that is a maximum voltage or maximum and that power point voltage here, and this is the current, the corresponding current here. So from the graph only you go to see what is where VMPP value and IMPP value. So because the scale you only choose the scale, please understand. So the most of the graphs So please you go to take the different students having the different skills they have chosen. Okay, you carefully now that is the reason I'm telling the power. You carefully see what is the scale. So exactly they go to meet at x-axis in that point. So what is the reading that voltage value, and similarly here that y-axis what is the corresponding current. So okay, that reading you go to taken from where your graph only, because already you have the graph that solar cell characterization graph. The same graph also you go to use once again, or by using the reading you draw one more graph. There's no problem. Okay, from that graph only you go to see what is that MPP and IPP value, and the product of these two. Okay, that IMPP and the VMPP, the product of this current and voltage gives what is the current and voltage? What is the product of current and voltage? Is equal to what
Power.
is the power? So that is the power. That is the maximum power. That is the maximum power. So the maximum power point. See, that is a ratio they are telling here. That is maximum power point MPP like that. So the maximum power is calculated only by using this graph. So from the graph only you go to calculate that current, maximum current and maximum voltage. So from that the maximum current and voltage you go to multiply both the current and voltage, and you get the power, maximum power. So that is the first one. So after take the readings, immediately you go to draw the graph. So from the graph you go to calculate what is the maximum power value. Then again come to the experiment. In that solar cell experiment, you are using the solar panel and as well as the bulb also you are using. So now we go to see the formula first. What is the formula you are using here? So the formula is eta. The efficiency of the solar cell is okay calculated by, and that eta is equal to the PMPP. Just what I told. That is the maximum power point or maximum power divided by that A I naught. A is nothing but the area of cross section of the given solar panel, and I naught is the intensity of the light. Okay, the PMPP divided by A I naught, then whole multiply by 100. So when you go to multiply 100, you get the efficiency. So this is the ratio, and multiply with 100, you get the percentage. What is the percentage efficiency of the given solar cell? So the maximum power you go to calculate by using that formula IMPP and VMPP. So these two values coming from where? Your graph. Then the area of the solar panel, how you go to calculate? The dimension they are mentioned here. See here, that is 7.2 centimeter length and 4.5 centimeter breadth. So simply you go to multiply this, you get the area of cross section of the given panel. Then what about the intensity of the light? The intensity of light, you go to calculate from the power of the bulb divided by 4 pi d square. So the power of the bulb is already mentioned that each and every panel we are using the bulb. The power is given, that is 65 watts or 40 watts or 75 watts or 100 watts. They are using certain bulbs, different watts bulbs. 100-watt bulbs is there, or 60 watts or 75 watts or 45 watts like that. So the power of the bulb is given, no problem. Then D is the distance between the solar panel and the bulb. Just I already told. You keep the least distance, that is a 10 centimeter, then only you get the maximum intensity. So that distance you go to assume 10 centimeter. Okay, anyway in the assignment already the values are there, so please you go to understand. Okay, by using these values now, so by using that D and power of the bulb, we go to calculate the I naught, that is intensity of light. So then by using all the three values, that I naught, A and P, you go to calculate the efficiency. So the efficiency is always you go to give in between. Already I told the efficiency is not more than 20%. So maybe that is in between 10 to 15 or 15 to 20 like that. Okay, that is the efficiency of the given solar panel or given solar cell. So that is the experiment. So now simply I go to show the video. Please at least you go to listen to the video. That is only few minutes. So the sir will explain how you go to take the reading. Okay, please wait. I go to share the video. Please wait. See whether that video is visible. Please confirm.
Yes, sir, it's visible.
Okay. Just wait.
morning. Today we discussed on the experiment.
Just wait that voice. It takes just a few seconds.
The aim of this experiment is to explore the solar cell renewable energy sources and test their efficiency in converting solar radiation to electrical power. So this is a simple experimental setup shown in the figure. So apparatus required is solar cell, a variable resistor, digital multimeter to measure the voltage and the current, and an usual standard electrical lamp, etc. Though this experiment is to find out the efficiency of a solar cell, we are not going to use the solar radiation, but instead we use the standard electrical lamp to measure the efficiency of the given solar cell. Okay, so this is the experiment. You have a solar cell, and that solar cell is connected to both voltmeter as well as the ammeter. The principle behind this solar cell experiment is light energy is completely converted into electrical energy. Okay? So the formula for computing the efficiency is eta is equals to P divided by E into A into 100. Where P is the input power, E is the applied input voltage, A is the area of the solar cell, given solar cell. Okay? So we have, this is the experimental setup. This is the complete setup of the experiment. We have a light, a standard electrical bulb that was enclosed in this rectangular box, and we have a solar panel. That panel was enclosed inside this rectangular box. Okay. So this solar panel is movable, and the solar panel area, the dimensions of the solar panel is given as 70 into 45 millimeter. Okay. So we need to compute the area which we are going to use it in the formula. Therefore, we have the dimensions of 70 into 45 millimeter, and you have to square that. Okay. So the experimental procedure is very simple. So you have a variable, you have a voltmeter and then ammeter, and you have a variable resistor. To start with, we have to connect this entire circuit, and you have to maintain a minimum of 3 voltage. Okay? So what happening here is the light radiations that is emitting out of that box is completely absorbed by the solar panel that is enclosed within this box. So once the solar radiation, the light radiations are completely absorbed by this solar panel, then electrical charge distribution takes place. Charge split is takes place. That is, all the positive charges goes to one side and all the negative charges goes to the other side. So this splitting of charges will finally result in a flow of electric current in this circuit, external circuit, and that electrical current is measured. So what we are going to do is, we set a minimum of 3 voltage. That can be fixed by using this variable resistor. And this solar panel, you have 4 reference positions are there. By tuning the reference position accordingly, we can compute what is the electrical power generated, electrical current generated, as well as the voltage developed. So I fix this position as the first position. Then you can measure this voltmeter reading and ammeter reading. Then you can turn this. You can change the position of the solar panel, and I fix it somewhere here, second position, and you measure what is the current as well as the voltage. Similarly, you can go for the third reference position like this.
See, students, listen. Yes, can you hear me?
Yes, sir.
Yes. See, see here the sir going to explain how you go to take the readings here. You fix the readings initially, but already previously we did at one position. For example, the maximum position. So you vary the resistance from 10 to 22, 47 like that. Okay, that is also one more method. So here now you are using this previous method only. There is no problem. Okay, you don't take this type of readings. Yeah, at least you go to rotate the resistance. For variable resistance, you go to fix what is the voltage and current. Okay, already you did the same. You go to follow. Okay, don't get confused. By using that only, the reading only, you go to calculate what is the efficiency of the solar cell. Okay. But anyway, that video I go to upload it in your GCR. So please, so individually all of you go to check. Okay, just to see the video how you go to take that experiment. Okay. Just wait. So now I move on to the assignment part. Just wait. Okay. See, what about more? Now the screen is visible. Yes. Assignment screen is visible or not?
Yes, sir.
Yes, sir.
Okay. Okay. So see, the aim already told that you go to determine the efficiency, and the formula is already explained. What is P maximum? That P maximum is nothing but the maximum power. So that is simply calculated by that IMPP and VMPP like that. Okay, when that maximum power at the current and maximum power at voltage, and the product of these two, you give the maximum power. And the area of the solar panel already told, that is 7.2 centimeter into 4.5. The dimension is given here. The 7.2 centimeter length and 4.5 centimeter width. So you go to multiply these two, you get the area of the cross section. Okay, then, and what about intensity? That intensity is by using the power of the bulb and the distance between the solar panel and the bulb. Both the values are given. What is the power of the bulb and the distance is given. By using these values, you go to calculate what is the intensity, I naught. Okay, that's all. So in the reading, see the table column, this is the maximum position. So in the intensity is maximum. Okay, in that position, and now I go to vary the resistance here. See, for the different ohms, 10, 22, 47, 56, like that different resistance. Now I go to take the readings, both voltmeter as well as ammeter reading. I think sir already told that is a 3 volt reading like that. See here. So almost here you get 3. The first two readings, that starting from 1.7 and 2. After that, almost you get 3 volt here. So almost most of the light is gathered by the solar panel. So that time the current suddenly decreases. See here. So you get 3.6, 3.8, 3.9 like that. Voltmeter reading goes on increasing. At the same time, your ammeter reading goes on decreasing. Okay. So the graph is like this. See here, your voltmeter reading is increasing. The ammeter reading goes on decreases like that. So from the curve already told, you go to choose the point where the curve is exactly turned. So you go to choose the point and you draw the line. From the origin, you go to draw the line. So from that point, you go to take the perpendicular lines from parallel to both the x and y axis. Then you get the values, that VMP and IMP. By using these values only, you go to calculate the power. Then the power of the bulb is given. So that is 75 watts. And the distance between the solar panel and the bulb is also given, that is 10 centimeter. So by using these two values, you go to calculate the intensity by using that formula. That is the power of the bulb divided by 4 pi d square. The d is replaced by that is a 10 centimeter, d square, 10 centimeter. Convert into meter. Okay, all the values you convert into meter, no problem. Okay, then maximum power already you know from the graph. You know what is the maximum power. Then by using these two values, you go to calculate intensity. So area is also given. Okay, the area of the panel dimensions already is given. So now you go to calculate all the 3 values, power, intensity and area. If you know all these things, so directly go to calculate what is the efficiency by using this formula. So the formula already is there. So power maximum divided by A I naught into 100. So that is a way how you go to calculate the efficiency of the given solar cell. We come to the assignment part. So the assignment part, what are the assignments here, the questions? The first, by using the readings. By using the readings, the table column, you draw the VA characterization curve. Those who already having the graph, so this reading is similar to your experiment number 5. So please understand, those who already having the graph, that VA characterization graph for max intensity, you go to use the same graph. Okay, you no need to draw the one more graph again. By using that same graph, now you go to calculate the power, the maximum power. From the graph, you find out the maximum power. I will explain how you go to calculate the maximum power by using that graph. Okay, you go to follow that one. Then by using the readings, that the power of the bulb and the distance between the panel, so you go to calculate intensity. Then also you go to identify what is the area of cross section with the help of the dimensions. So once you go to calculate all these things, all the 3 values, then you go to calculate what is the intensity, efficiency. That's all. Then you write the results. The efficiency of the given solar panel or the given solar cell is so and so like that. Are you understand? Yes? Yes or no?
Yes, sir. Yes.
See, any clarifications or any doubts here, Mo, for this?
No.
See,
No.
that the experiment already we did here, that the solar cell experiment already have. Okay, the readings also already have. But anyway, the assignment I will be posted this year, no problem. But at the same time, okay, you go to draw the graph, or if you have already have the graph, by using that graph, you go to calculate what is the maximum power first. Then by using the readings, that power of the bulb and distance between the bulb and the panel, you go to calculate that intensity of the light. That area of the panel is also mentioned. The dimension is given. By using that, you go to calculate the area. Then you go to calculate what is the efficiency. That's already simple. Already I told the efficiency is in between. For example, if you get the efficiency is 3% or 4%, that is also correct. But the efficiency not beyond 20%. Please understand, not beyond 20. Maybe the value is in between. You go to take the 10 to 15 or 15 to 20. Sometimes based on this reading, you get 3% or 4%. That is also correct because that is a small panel only. That is a small panel that the dimension is very too small. Okay, definitely the efficiency is take the 8% or 6% or something, whatever you get, that is okay. That is based on your graph. Okay, how you go to calculate that maximum power. So whether the scales are already fixed or not, like that you go to understand. Okay. Yes, but the efficiency is not beyond the 20%. If you calculate the efficiency 30%, that is completely wrong. That is not correct. So please take care. Okay. Yes. Okay. Just wait. Just wait. I will come. Just wait. Day after 5 lab, lab session, sir. You understand? See whether I understand or any doubts or clarifications more, please.
No, sir. No, sir.
Okay, then I go to stop the share screen. Please wait. Okay, so anyway, so after this class, I go to upload both video as well as assignment. Okay, so please all of you go to take this one. Okay, and by using the readings and the graph, you go to calculate that each and every one. Okay. Yes. Anything else or anything or any clarifications, please. Nikhil, what about your CRE? Where is your? So see, Nikhil, you go. I say tomorrow onwards, you go to follow the new slots. Please inform to students. Okay. Tomorrow, no problem. Day after one, we have the classes same, but instead of 10 o'clock, now 9:50 now, 9:50 to 10:40 like that. Okay. So please understand. Then day 3, day 5, you please inform the students. Okay. What are the classes timings? Lab also day 5 in future. That is a day after 5. Morning session only have lab from 10:50 to 12:30 like that. Okay. So just wait. I think almost it's over now. Just wait. The attendance. Hey, what about register number 70 is left? See here, Nikhil. I think 70 is left. 70, the number is not there in the URP more. I think he is left. That Parikh. I think that Parikh, register number 70 is not there. Number is not there in the URP. Now the total is 71 now, class 10. So the attendance at 12. Okay. So, okay, 51.
Present.
52. 52 is not there. 53.
Yes, sir. 52 is there. 52, sir.
52. Okay. 53.
53.
Okay. 54. 55.
Present, sir.
56. No, 57.
Present, sir.
Okay. 58. 58. Nikhil. Okay. 59.
Present, sir.
60.
Present, sir.
61.
Present, sir.
62.
Present, sir.
63.
Present, sir.
65. I think 65, yesterday you make a call that fellow, 65, what about today's? 66? 66, Aditya Swami,
He is present. He wrote in the chat.
okay,
He's
67,
having some network issue.
okay, yes, okay, so 68,
Present, sir.
69,
Present, sir.
okay, 70 is not there, okay, 71,
Present, sir.
72,
Present, sir.
73,
Present, sir.
74, 74, okay, 75,
Present, sir.
76,
Present, sir.
77,
She also wrote in the chat box. Some
yes,
electricity.
okay, 77, okay, 78,
Present, sir.
79,
Present, sir.
okay, 80,
Present, sir.
81,
Present,
Vishwa
sir.
Jha. Yeah, it's there, okay, 83, 83,
Present, sir.
84, Ashutosh Sharma, 84,
sir. Present,
85,
Present,
80,
sir.
87,
Present, sir.
88, see, okay, 89,
Present, sir.
90,
Present, sir.
91,
Present, sir.
92, Sri Krishna Prakash, absent, 93,
Present, sir.
94, 95,
Present, sir.
96,
Present, sir.
97,
Present, sir.
99,
Present.
99, Mugundan is there,
Present, sir.
okay, 100,
Present, sir.
and 101, 101, it's not there, okay, 102,
Present, sir.
103,
Present, sir.
104,
Present, sir.
105,
Present, sir.
okay, 6, Sharma, that
So
Harmo is not there.
58 is present, sir. He wrote in chat, sir.
Okay. What about 106? It's not there, okay. 107,
Present, sir.
109,
Present, sir.
110,
Present, sir.
111,
Present, sir.
112,
Present, sir.
113,
113 present, sir.
114,
Yes, sir.
115, 115, Shubham Gupta, it's not there, 116,
Present, sir.
117,
Yes, sir.
118, 119,
Present, sir.
okay, 119, 119, Adarsh, it's not there, 120,
She wrote in chat.
okay. 1189,
Present, sir.
1190, 1190, 191,
Present, sir.
okay, 192 is present, okay, 193, Bhai Patel,
Present, sir. Present.
292, Sashank Sri Sarma, 292, okay, 293,
Present, sir.
377, Roshan,
Yes, sir.
380,
Present,
Aisha.
sir.
Okay, see, once again, listen, yeah, the register number 53, 54, it's not there, absent, then 74, 92, 101, 106, 115, 119, 1190, and 292. See, I'm
Sir,
10
58 present. I got
58.
network.
58, okay, 58 market present, no problem. Okay,
Yes, sir.
okay, see, any doubts or any clarifications regarding this experiment? Any doubts or any clarifications, please? Otherwise, you can leave now.
Sir, 119 present.
Yes,
119.
11?
119. 119.
11, okay. 119, okay. Others, okay, ma, okay, I will take care. Any other students?
Sir, 94 is present, na?
94%, no problem. 94%. 92 absent, 92 only absent. Okay, ma. Okay.